Hey, hello everybody. Hello once again to the first of this week's Encode X Fuel Educate event. Today we're continuing with another amazing guest speaker from Envio. We're joined by Joss, who's going to tell something about fast historic data querying with HyperFuel. Hi Joss, how are you doing?
Good. How are you? Happy
Good.
Monday.
Thank you. Happy one to you as well, and happy to everybody else. Yeah, if you have any questions, guys, you know the drill. Feel free to pop them in the chat or in the questions tab. And until then, Joss, the stage is yours.
Awesome. Thank you. Yeah, thank you for the introduction. So I'm going to be talking about fast historic data querying with Envio's HyperFuel today. A little bit about myself briefly. I'm Joss, got into the blockchain space around 2020, uh, and then heard about it then when I was in university, started taking some classes, was president of my university's blockchain club, did some research, TA, really bought into the whole decentralization ideology of it. And then May 2023, I graduated. And since then, I've been working at Envio as a backend Rust dev. Um, I'm based out of Boston, Massachusetts, but I like to travel a lot. This year, I've been to 7 countries, and the picture on the right was from a few weeks ago. We had an offsite in Norway with NBO where we went on this. It was like a 25-kilometer, 12-hour hike to this vista in Norway. Super cool. But anyways, okay. So to talk about NVO, first I have to talk about Float. Float was the team's previous venture in the blockchain space. Float was a DeFi application for longing and shorting digital assets. That doesn't really matter, but what's important here for context is that they had a ton of smart contracts, ton of data that they had to display on their front end and on the user pages. And they used the graph for kind of plumbing this data in from the blockchain to their front end. But since they had so much data, the graph kind of got congested often to the point where there was a 5-minute delay for something happening on chain for it to show up on their website, which, horrible user experience. They had to put a little bar at the top saying, please wait 5 minutes to see your UI get updated. And then additionally, on the developer side, each time they wanted to make a change of what data they wanted on their front end, they had to resync their whole indexer, which is common practice for indexers. But the thing is, it took a week to sync. So imagine hitting the sync button. You're 6 days in, then it hits an error, then you have to start over. Then it's basically 2 weeks lost at that point. So they kind of got fed up with that and went on a little mission to build their own indexer, which turned into Envio today. And Envio seemed to actually work pretty well. We got some pretty great speed in it. This is a benchmark that's pretty outdated now, like 9 months. And also on the EVM side, it took 9 minutes to sync a Uniswap pool on Envio compared to 13 hours or 16 hours for some other indexing solutions. And so they brought down their time from 1 week to 1.6 hours. So really fast. People liked it a lot. We get a lot of great reviews, people DMing us. We actually have a channel in our internal Discord where we just post screenshots of user reviews, which is like super gratifying to see. But that brings us to Fuel. So we heard that Fuel kind of had an opening, had some people asking for an indexer. We were only EVM at the time, but we decided that Fuel would be a great time to try out being really cross VM as an indexer data solution. So we hard forked our whole code base to support Fuel VM. And that's where we're at now. We fully support Fuel VM. So we went over why we needed it at Float, how much faster it is. Now we'll go a little bit into how we do it, just at a high level. The secret sauce is HyperFuel, which I'm going over today, how to use. And HyperFuel, you can think of it kind of like a node, but just for reading data. So it doesn't do anything like consensus or execution or participate in the peer-to-peer network. It is strictly just ingesting all the data on the Fuel chain and exposing it to users through a custom query structure. And the I guess, architecture of it is basically it's a custom database written in Rust that uses Parquet files as the backend for the storage of the data. Brief overview of Parquet is it's a column-oriented file type, which contrasted to row-oriented file types. Row-oriented files were kind of like the standard from the dawn of computers up until, I don't know, something like 10 years ago, something like that. You can see here this diagram in the middle is kind of like the logical interpretation of how you would lay out data. You have your ID, last name, first name, bonus, etc. And row-oriented data, they're all laid out next to each other, so an entire entity next to each other. But in column-oriented data, you put each column next to each other in memory. So, for example, if you want to query ID and last name, you didn't care about first name or bonus. In row-oriented, you would have to load in all 4 of these memory locations and then manually parse out just the ID and last name. In column-oriented, you can just grab these first 2 locations here. So literally like half the data that you need to read into memory, which turns out to be really, really great for blockchain data because blockchains have a ton of data, but 99% of the time you only care about a certain subset of data. For example, if you're making a front end for your contracts, you really only care about the logs and you don't care about other fields like the previous block route or the current or the gas fees on a certain block or things like that. So you can really get a lot of performance improvements by using a storage layout like that. And to put it into context for Envio, HyperFuel is kind of our backend data analytic database that powers our indexer HyperIndex. So for you'll use HyperFuel if you want to fast historic data queries. So things like chain data analysis or block explorer, and use HyperIndex for more smart contract specific tasks like data for Adapt's front end or data analysis on a specific smart contract. You can use HyperFuel, and we have a Rust client, TypeScript client, and Python client. And HyperIndex you can write in JavaScript, TypeScript, Rescript. And today we're just focusing on HyperFuel, but if you want to learn more about HyperIndex on Fuel, it's a super great developer experience, really similar to writing graph handlers if you're familiar with that. But my coworker Dimitri just gave a great presentation on Friday with this same Encode Fuel bootcamp on HyperIndex for Fuel. I'll link to it in the end, but highly recommend that as well. Okay, so for HyperFuel, here's some examples of why you might want it, some specific data that you could be looking for. HyperFuel really shines when you're looking over a wide block range for some specific data or data that matches a specific pattern. For example, all mint transactions or all transfer receipts of a specific asset or all inputs from a predicate or values returned for a contract, things like that. So I'm going to show you briefly a demo of making a query for all addresses that's received some asset. I'm just going to flash it to you, just show you the speed real quick, not explain it. Then we're going to take a step back and kind of explain how the query works, and then go back to it, step through it. And then the second demo will be a bit of a larger example of how you can retrieve all of the balances of all of the NFTs on Fuel. Just grabbing some water. All right, so for that first demo, we'll be using our Python client, just because Python's nice and easy to look at. And I'll zoom in here. So we'll come back to this in a second and explain it, but basically we write out our query, make the request, and then we're just going to print out all the data and how long it took. And again, this is a query for, we're printing out all of the addresses that have received this asset in block range 0 to 1.3 million. So I was tabbed away, but took 120 milliseconds, tenth of a second, to find all 7,000 receipts in 1.3 million blocks. And this is just all the data that is printed out. So let's go back and see what actually happened. So first we got to explain how Fuel lays out its object structure. So you might be familiar with the EVM object structure, which is you have a block that contains a list of transactions that contains a list of logs. Fuel is very similar, but has some notable differences. Similarly, you have a block, has things like, block ID, height, previous route, and it also has a list of transactions. Transactions contain, transaction ID, status, scripts, blah, blah, blah. But transactions also contain a list of receipts. And Fuel has 13 different types of receipts, notably log receipts, which is similar to what EVM logs are. They also have receipts for mint, burn, contract return data, etc. Transactions also contain a list of inputs, which is things like coin input, message input, UTXO, predicate input, and it also contains a list of outputs, which is coin output, contract creation output, etc. And so the HyperFuel query works by you first decide on the block range that you want to query, then you decide which receipts, inputs, or outputs you want to load from that block range, and then you have to specify what data fields you want to return from that loaded data. So go back to the example that I just showed you. So coming back to the query here, we first decided our block range. We're just saying 0 to 1.3 million. And then the second part, which receipts, inputs, or outputs do I want to load? For this example, I just care about a specific receipt. And we want to load all receipts where the asset ID, the field asset ID matches this asset ID here that we supply, and that are of receipt type 8, which are transfer out. There are like 13 different types of receipts. And then the third part, what fields do I want to return from that loaded data? So this part basically said load all of these types of receipts. And then this part here, the field selection, is saying what data do I want from the receipts that are loaded. And in this case, we just want transaction ID, block height, and to, like what address is on the to field. And in our docs, you can see a list of all of the different fields that this is basically a one-to-one comparison of the actual Fuel schema. But we just wrote it out for convenience, all of the fields that you can return on. So in this example here, we're loading a bunch of receipts. You can return any of these fields that you want for the receipts. Similarly for inputs, outputs, transactions, blocks. But if we go back to the output of this script, you can see all this printout. All these nones are data that we didn't want, we didn't specify. And then you can see things like asset ID here is a field that we wanted returned, etc. Yeah, and I guess next I can show a little bit more of an involved example. So this example is HyperFuel query using our TypeScript library to query for all NFTs, current NFT balances over the whole Fuel blockchain. So it does take a minute to load. I ran it previously, and I'll just show you the result now. You can see this little printout at the bottom. It took 15 minutes, processed 6 million receipt objects over 5.7 million blocks, which is a ton of data. It took 15 minutes to process every single NFT, mint, burn, transfer over the entire Fuel blockchain. And then just here is just a dump printout of all of the NFTs. So for example, from this minting contract, you have all of these NFTs, and it lists the NFT ID and the current owner. But we can look at what the script is actually doing. So here's our query structure. First part is you specify the block range you want. So you have from block, just starts here, but you might also notice that there's no to block. If you don't specify like the end block your query runs to, it runs up until the head of the chain or until it hits an internal time limit. And if it hits that internal time limit, it'll return and tell you what block it got up to. And that way you can do pagination, which we'll see later here. And the second part, we determine what data we want. So for this one, we say we just want receipts, and we'll load any receipt that is of type 7, 8, 11, or 12, which is transfer, transfer out, mint, or burn. Because in Fuel, the 4 ways that an account's asset balance can be changed are, transferring, being transferred to, transferring from, or from a contract, be minting or burning a asset. And then these are all the fields that we want that we're going to be manipulating. And I'll just walk through this because it gets kind of verbose. But basically, this is the main logic loop here where the pagination happens. We make the query for the data, and then it tells us what block it got up to in the query. So that way we can make the next query starting at the previous block it got up to. So basically stepping through the whole chain. And then we iterate through every single receipt and basically just format it into our hash maps. So for mint receipts, mint, simple, just increment somebody's balance. Burn receipts, similarly, just decrement someone's balance. Transfer receipts involve 2 parties, so you're gonna have to increase someone's balance, decrease somebody else's. And then transfer out, also similar to transfer. And that's basically all that this logic does here. So it's relative. I guess it's more complicated than the previous example, but logically it's still pretty simple. Don't let like all the lines of code confuse you. There's a ton of refactoring you can do to make it a little bit quicker, a little bit cleaner. But yeah, and I guess now would be a good time if anybody has any questions.
Yeah, come on, guys. Let's give some questions. Let's give this. Yes, it looks like somebody's typing. Let's give it a couple of more seconds.
Oh, and thanks for pasting that link.
Yeah, no problem. It was the workshop last Friday by Dimitri. The question from Bob: is it batch only, or can it listen for new transactions as a background process?
Yes, it can. You can set up just like polling, for example, in the current. But also earlier, how I mentioned that, we first were targeting EVM and wrote all this stuff for EVM, and then we forked it to Fuel. The EVM HyperFuel clients do have a nicer API for, listening at the tip streaming data. That's going to be ported over to the HyperFuel versions when we get a chance. But yeah, so right now you would have to implement something like we did here with just basically a while loop and just looping. But yeah, no, there will be streaming. That's a great question, Tom. Yeah, honestly, it was just kind of like a green. Tom was asking how come you decided to expand from EVM. It's just kind of like a greenfields, like, hey, we heard of this, maybe, looked at it, looked like some people were asking questions about an indexer. So they kind of just said, hey, Joss, like, check this out, spend a week or 2 on it, see if it might be worth it, see if it might be possible. It'd be like, good market to go into. And yeah, we wasn't, there's definitely some road bumps, but we got it done. And, people, like, it felt like great, I guess, product market fit. There's, people were literally like DMing us like every day, like, hey, are you done with the indexer? Are you done with the indexer yet? And yeah.
Awesome. Any other questions right now?
Yeah, or if anybody, wants to see any specific examples or something like that, because that's all the slides I had. I could go through an example for somebody if they want, though, or maybe show some more of the pre-made examples.
Yeah, I think that would be a good idea for right now. To go with some of the pre-made examples.
Mm-hmm.
And then as questions pile up, and I think they will, because I see a couple of people typing, maybe we can address them in a little while.
Yeah, sure. So this is another pre-made example. We have a kind of a preset function here that to get logs from a contract address, all you have to do is specify a contract address, a block range, and it'll get all the logs in that block range for you. So we can run that. And this is all the logs for that contract over, the 5.7 million blocks. So half a second for 14,000 logs. And this returns, all the log data that you need for using the fuel decoder. And also maybe we can play with this example a little bit. Yes. Do you have a GitHub repo and some docs we can use to go over all this personally? Yeah. May as well just link it all now. Here's a bunch of links. I'll just paste this all in the chat. There you go. And that's also, it includes links to the docs and the examples that I'm going over. And also definitely join our Discord. We're super active in the Discord. And we work at a Discord as well. So it's, easy to just check the dev help channel. But yeah, so if we want to play with this received assets example, see it took 82 milliseconds, 7,000 receipts over 1.3 million blocks. Let's try to change that to, let's do 5.7 million blocks and see how much longer that takes. So, okay, same speed, but 4,000 more blocks of searching. So you can see it's like really performant at searching long, like wide ranges for specific data, which makes it naturally a very good fit for powering an indexer that looks for specific log data from specific contracts, which is what HyperIndex is.
Cool. Awesome. Do you perhaps have any other examples, or do people have any questions about any of this? Now is the great time to answer any of them. Come on, guys, don't be shy. Until people ask questions, I do have a question actually. What kind of, this is obviously a very practical workshop, and I assume people will take all this like information, GitHub repos and stuff to build their own stuff. So my question is the very traditional one. What kind of stuff do you like to see built with HyperFuel? What kind of projects do you usually like to see being built?
So the stuff I guess I like to see. So we have some people doing some researchers doing data analysis using HyperFuel as kind of on the EVM side. I don't know if you're familiar with cryo, but it's like as a cryo alternative. So for example, we know this guy who's been doing a lot of research on things around blobs and like gas fees. So he has his whole suite set up using HyperFuel or HyperSync to query all that data. Also, another one that I've seen that's really cool is block explorers and transaction explorers. Because HyperFuel is so fast, you can make a whole block explorer like without a backend. You don't have to make the queries beforehand and store them in your own database. You can literally just have a front end that when a user clicks on a transaction, it just directly makes a HyperFuel query, and that's really fast and pretty cool to see. Actually, one of our let me go back to it here. In one of the user reviews, some guy making a block explorer said it literally beat his front end. Actually, no, this isn't the guy making the block explorer, but yeah, it beats out a lot of things just because of the speed. What happens if there's an unforeseen issue during indexing? Will it start over or pause there, continue after some time? We have it set up to pause. So we do, a bunch of data validation when it ingests data, and it pauses when it runs into an issue and pings us, and then we go in, figure out what happened wrong, fix it, and then reindex. David, what's next for Envio? It's a great question. I guess getting more users, spreading the good word. Come check us out. Come in the Discord, check us out.
Yeah, that's a very valid answer. Any final questions, guys, before we wrap it up? Unless Josh, you have any more examples you might want to go through.
That's it for now. I could show like the examples in the other clients, but they're a lot more verbose, so they look a little bit scarier than Python. But yeah, so we have like the examples that I went over today, and TypeScript and Rust as well. No, that's about it.
Cool. Amazing. Then I think we can slowly wrap it up today, a little bit earlier than expected, but that's perfectly fine. If you have any questions, feel free to go over to the Envio Discord. They're a terrific bunch of people. I'm sure they will help you in any way they possibly can. And Josh, any final words of wisdom for the audience?
There's really cool possibilities for indexing on Fuel because of how Fuel's like data model is set up. They emit like everything on chain, like they emit every burn, mint, transaction, in even contract call return data on chain, which EVM doesn't do. So there's some really, really fun possibilities for data to play around with on Fuel. Definitely recommend checking it out.
Yeah, do check it out. Thanks once again to Josh for coming in for the workshop, and thank you everybody else for coming and listening in. We'll see you on Wednesday for the next session for series about predicates. Until then, have a long rest of the day and see you around.
Thank you. Bye.